afternoon, everyone. Can you hear me okay? All right, thank you. I just want to start by saying thank you to Lokesh and the CCWT team for inviting the Water Authority here today. We're excited to collaborate with you again and also to talk a little bit about what our efforts have been as a water supplier from that perspective. So first, quickly, just who is SCWA, because there can be misconceptions for even Suffolk residents because of our name, Suffolk County. We're not a county agency, we're a public authority. The takeaway from that is we don't have the ability for taxing, we don't have investor dollars coming in. We're a not-for-profit, essentially. So anything that we make in terms of our rates gets pushed right back into the system in terms of building and treatment and maintenance and operation. We do serve approximately 1.2 million residents. The size of our system, we're a large system. 640 wells at over 240 pump stations. We have a total storage with our tanks of almost 74 million gallons, average daily pumpage of 220 million gallons. And like every other water supplier, we have an average peak pumpage that's much higher than that due to irrigation. It's 455 million gallons a day. I'm sorry, a month. No, day, sorry. We have 36,000 hydrants covering 6,000 miles of water main. So, like I said, very large system. So how do we ascertain our water quality? Well, we have our own laboratory, the largest groundwater laboratory in the country. We test and sample at head of pump so we can see what exactly is it that's in the raw water, what's in our groundwater. We test at various stages of treatment, if we have treatment at that site. And we're also testing post-treatment before we go into the system, and finally in the distribution system itself. Our lab processed 95,000 samples last year. Over 195,000 tests were performed on that samples. They're open 7 days a week, 365 days a year. We also test at a higher frequency than we're required to, and our in-house standards in many cases are stricter than what we're required to have. So specifically on our action on PFAS and PFOA, began testing back in 2013. The health department, as you know, 10 parts per trillion is the standard for both PFAS and PFOA. The EPA has since proposed a level of 4. We moved right away to try to meet that new proposed lower standard. And so we tried to formalize a plan and actually have successfully executed in that we have a mix of treatment and operational restraints that have us in full compliance already, years ahead of the EPA suggested deadline. It went from 2029 to 2031 recently as a proposal. I would also like to point out that as important as the focus on contaminants is, and it's extremely important for the public and for us as water suppliers, we also need to be able to balance that by letting our customers know that the water is generally safe. And towards that end, 2/3 of our wells, of those 600 some odd wells, don't require any treatment at all at this point. So in rolling out our PFAS treatment, we rely on institutions like CCWT and Stony Brook for some of the research that they're doing, but also on our in-house expertise. We have a mobile GAC system that's pictured here after a recent repaint. Those are 8-foot diameter vessels. We've used them in the past for carbon treatment of VOCs and things like that. We sent that out to one of our sites with the highest levels of PFAS and PFOA in the beginning, and we tested different carbons. Real world, let's see exactly which one is going to work best for us. We've done a lot of carbon research and had kind of standardized around coconut for most things, bituminous for some things, and quickly learned that we were going to be swinging that back around towards virgin bituminous for PFAS and PFOA. So once we had established that bituminous was the way to go for us at this site, we installed a permanent GAC system at that site. We took our trailer back and we retrofitted using in-house forces and changed it over to an ion exchange resin system. And we talked with our partners, 2 of whom are here today, Jason Heim and Josh Mednick, at the County Health Department. Got approval to use a resin that we were already using, perchlorate resin, that was going to work here. We were able to get really quick approval on getting that into a system. get it out of sight and start working with it. Found that that was going to be effective for us at that site, changed over to a permanent system, took that system with the same bed of resin, and that's currently treating another well now. So we're able to adapt fairly quickly to these things. The procurement process can take a long time on GACs. Just from the time you go out to bid to the time you actually get a GAC can be anywhere from 6 to 8 months. We're also finding that besides the cost, like resin promises to be more effective in terms of cost when you factor in both capital costs and O&M costs over carbon. You pay a higher cost up front, and the promise is for a longer bed life that you'll make in the meantime. What we're finding, though, is a lot of times we're actually site-driven. So if I have a site that doesn't have good drainage, I might decide to use resin at that site instead of carbon, because carbon takes a lot more to backwash. The resin, I can rinse it, I can do my sampling, get it into service. The carbon may just not be viable at a site. And also, what are the other co-contaminants, if any? If there are more, maybe carbon is the right answer. In terms of 1,4-dioxane and AOP, we began testing for 1,4-D back in 2003. 2016, we received the first full-scale pilot approval in New York State, treating 1,4-D down to non-detect. We currently have 19 systems. Before we did that full-scale pilot, we actually had done a pilot with Trojan back in 2011 at the same site. So that was the very beginning for us. And we were able to convert the full-size pilot into the first in-service unit in New York State in 2018. So we were about 18 months ahead of the MCL being established by the state. That's a picture. It's kind of difficult to see. It's a little dark, but it's a smaller reactor that was used on a side stream for that first pilot. Even though we've kind of standardized around a UV peroxide system, we're still taking a look, and always will, looking at different systems, what else is out there, is there a better mousetrap out there for treatment? And towards that end, we had done a collaboration with CCWT, some of Long Island's largest engineering consultants and other water suppliers here, in trying out different AOP systems, including a dark system, a peroxone system, and also a UV chlorine system. Our AOP designs are done in-house. This is an example of one of the 3D renderings for a project we were doing up in the Northport area. It's a 2 AOP system. This is the actual system after it's built. And then the designs themselves are constantly evolving. We're trying different things. In this case, we had a site that had a lot more room available to us, which is believe me, a big blessing. A lot of these sites are so tight, they're very difficult to construct anything on. At this particular site, we had tons of room, so we said, what could we do when room wasn't a limiting factor? Have a larger building. We're able to fit 3 AOP systems into this at the ultimate build-out, and we also recessed the piping, that fiber grate you see there. We're able to lower the piping to make it easier for our operators to come in and service the system. So to summarize our response, it took a lot of R&D, both internally and in collaborations with institutions like Stony Brook CCWT. We've worked with NJIT. We continue to work with UNC Charlotte in characterizing our water to inform our AOP designs. And we've also worked with the County Health Department in getting approval to put out a reactivated carbon contract. And that's a huge thing. And one of the reasons we're so excited about Project Charlie here is, look, I should showed you the budget numbers on carbon, those O&M numbers on the carbon changeouts. Anything we can do to extend the life of the carbon, or if the char turns out to be a substitute for, or just a life extender for it, we're interested and we want to be part of it. Currently in service, we have 165 treatment systems for PFAS. We have 19 AOP systems for 1,4-D treatment. We have 15 more AOP systems on order. 20 systems are out to bid currently for GAC. And we have 9 buildings where we're just waiting on Health Department approval for that contract, so we can go out to bid on that. And in the future, our work's not done. I tell my team all the time, we'll never be done, with this kind of treatment in our careers anyway. 91 more AOP and GAC systems, just with what we know today. and obviously there's more that can be coming at any given time. And in the interest of providing the best bang for the buck for our customers, we've been extremely aggressive in going after polluters with litigation for both PFAS and for 1,4-dioxane. We're also pursuing the grant opportunities that are available to us. New York State's been great with that, and we have $42 million in funding just to date. So, thank you.